Thank you all for coming. My name is Ben Jurgensen. The company is July Bicycles, and today I'm going to talk a little bit about my background and then the processes I use to make these bikes. I should say, I think the thing that's maybe like a little bit unique about these bikes and what I'll be talking about today is that I'm trying to build carbon fiber bikes using really, really accessible digital fabrication technologies. And I think that's maybe what separates my way of making, but is also an opportunity for a lot of other makers and builders. So my background, I teach at the Rhode Island School of Design in the sculpture department. So I have a background in fine arts and sculpture. And that's kind of how I got into this. So these are some installation shots of shows that I've done. These are, sculpture, for example, sculptures of bicycles. So not a rideable bicycle, but a sculpture of a bicycle. These objects are made, they're digitally fabricated, mostly made using CNC milling machines or 3D printers. And then they're coated in epoxy and or composite surfaces to make them more durable, and then painted using the same type of automotive systems you might use to coat a bike or a car or something like that. So that's kind of where I'm coming from in terms of making. A lot of the courses that I teach involve digital fabrication. So when people think of sculpture and traditional sculpture, you might think of metalworking or stone carving or something like that. But the tools that we're using now, are very similar to those in industry, right? So we're using CAD applications to model sculptures or 3D scanners, and then we're outputting to digital tools. So that's kind of where I'm coming from in terms of making. This is a more recent series of sculptures. They're all sculpted in VR. So using an Oculus headset, sculpted in VR, and then they're output to 3D printers and coated in epoxy and painted. So I should also say, if at any point you have a question, just shout it out or make eye contact with me. This is super casual, informal. So we'll just play it like that. So that's kind of where I'm coming from in terms of making. During COVID, I'm getting ahead of myself. Some projects that I'm working on that are bike adjacent, kind of like a bridge between sculpture and frame building. My kind of goal for the company is to make enough frames every year that I can fund some kind of interesting research and some interesting projects. And so two projects that I'm working on now are this kind of from memory bicycle. If anyone has stopped by the booth at the expo, I've got a sculpture of this. This is a series of images that were generated using ChatGPT's DALL-E. So I built a prompt that would draw bicycles from memory, and it's kind of like the collective memory of an AI model. It outputs these images, so you get all kinds of funky stuff. Like if you've ever even had a person draw a bicycle from memory, tubes are forgotten, things overlap, it doesn't quite work out. So the machine starts to do that as well. You get some pretty interesting stuff. So I built up an archive of these, and I'm slowly converting it into sculptures. So these get sculpted in VR, they get output to 3D printers. So this is the object that's in the show. Today it's printed on a large format 3D printer. Yep.
I'm sorry, when you keep saying sculpted in VR, what is it?
So there's a series of sculpting apps that you can use. If you're familiar with say a JPEG, like a 2D image, it's made up of pixels. These 3D sculpting apps use something called a voxel. So you kind of think of it as like a three-dimensional pixel. And you can put the headset on. It's very cool. It's freaky. You can put the headset on, and then you have your controllers, and you can literally sculpt with clay. And so I'm importing those images into that space, and then I can build them out into 3D. Great question. Yeah. And so that becomes a 3D model that can be printed. And so here's the object that's in the show getting 3D printed. The white is the ABS part, and then everything else is support material that gets removed later. That object gets coated in epoxy resin. It's the same resin system that I use for the bikes, and then it's painted using automotive paints. Some other things I'm working on are workshops. So I'm I'm an educator, fine arts background. I had the opportunity recently to go to Doha in Qatar and do a kind of a general composites and frame building workshop as part of the Tasmim Doha Design Biennial. So there was an exhibit of historically significant bicycles, and we set up a 2-day workshop, about 12 people each day, and we made composite tubes using 3D printed mandrels, and we did some compression molding. We all made head badges, and then we built up 2 frames in the workshop. So that was like a pretty cool opportunity as well. So there's some things kind of adjacent to frame building that I'm like also very interested in. Yeah, so the bicycles, kind of go through what I've been making. This is not a bicycle, it's a shoe. It's the kind of first carbon thing that I made that was bicycle related. During COVID, I had a little bit of extra time. I needed a new pair of cycling shoes. I thought, okay, maybe I could make a pair of cycling shoes. There's a couple other folks that have done this. So I 3D scanned my foot. I made a 3D printed last, and then I did a composite layup on that. I built the upper with like a leather material. I went a little crazy with the pinking shears. It's kind of retro, but it was a cool project, and kind of got me interested in composites, structural composites. So that's the bottom of the shoe. It's molded perfectly to my foot, so there's no insole. It just fits on my foot. And I thought maybe I could make a saddle. So I made a series of carbon saddles, all 3D printed molds, vacuum bagging the upper shell, and then casting the rails with tow in a multi-part composite mold. So it looks something like that. There's a saddle very similar to this one on the bike in the show if you stop by the booth. So from there I thought, okay, maybe I could make a frame. So this is frame 1. And in doing that, like each of these kind of steps add complexity. There's a lot of problem solving that has to take place and a lot of things that you have to kind of figure out in order to make the tooling and et cetera that's necessary to make the frames. Each frame I kind of iterated both on the kind of manufacturing process and also the design. So these frames are pretty simple, rim brake, road bike, everything's external cable. But it's all made by me. So filament wound tubes, cast dropouts, all of that kind of stuff. So I'll go through a few of these frames just to kind of give you a sense of what I'm making. This was part of a group of 3 frames that I made for 2 friends and I. We did the Mount Washington hill climb together. So this was my hill climbing setup for that. So the idea there is to make the, kind of the lightest bike you can get up that hill quickly in. So again, another carbon saddle. And then this bike was kind of the first bike that uses the processes that I'm going to show you today. So I was iterating in design of the bicycles, but also iterating how I made the bikes. And I finally arrived at a process that uses solely 3D printed tooling. So a series of, or a group of thermoplastics that kind of work in conjunction with each other to allow me to mold tubes and dropouts and things like that. So this was the first bike that I made using the process that I'll share today. I had the opportunity to take it with me to Doha. I worked there about 10 years ago. I set up a digital fabrication lab at Virginia Commonwealth University's satellite campus there. And the cool thing about this bike, and maybe something that was really special to me, is that the graphics on this, the Arabic version of my logo, were designed by a former student who now teaches there. So it was a very cool opportunity. There was a falcon on the bike and then in the souk, so it's kind of fun. These are some more recent frames. They're getting more and more complex, so no more round tubes. Every tube is shaped. The top tube of this bike is like an hourglass shape. So really kind of thinking about design and adding complexity there.
Are the decisions for shaping the tubes aesthetic, or are you kind of taking into account rigidity or performance for the bike or aerodynamics?
Great question, but both. Not so much aerodynamics, but definitely thinking about how the shape of the tube is going to affect the quality of the ride, or thinking about how I can create more area to bond things together, so on and so forth. Yeah. So it's kind of dictated both by aesthetics and also ride. So you probably noticed a lot of these frames are my size. So I ride them and test them, and then, it creates a feedback loop. So like the bike that's in the show now, I haven't actually ridden yet. I just built it up the night before the show. And so there's a lot of things that, like new things that I've tried in that frame, new layups. And so I'm really curious to see how that bike rides, and then, that'll get folded back in to future frame. So here's a disc brake road bike. And again, each bike is adding kind of complexity in terms of shaping. There's more and more precast parts in the frame, so starting to precast like things like seat stay clusters. So something I was thinking about with this bike is, in terms of aesthetics, how can you make the bike look like it's moving when it's standing still? And so I wanted to give this bike like a sense of potential energy. This might remind you of like maybe frog legs leaping forward. And so that was kind of the thought there. Also thinking very much about how a bike is seen. When we look at bikes in photographs, we see them in profile, right? But that's never how you see a bike when you ride a bike. So thinking about how it looks, or like ride with people riding bikes. So how does it look at it at 3/4, things like that. So, yeah. So those are some things that I've made and kind of where I'm coming from. And I'll talk a little bit about materials and process. So carbon fiber, there are a lot of people making carbon fiber bikes, in industry. There are a few small companies making custom carbon fiber bikes, and then there's maybe a handful, 10, 20 single person composites carbon builders in the US maybe, and double that worldwide. I don't know, there's not a lot of folks doing it. It affords you all kinds of opportunities in terms of design. That's not to say it's better or worse, it's just different. And to me, it's those opportunities are interesting. So that's kind of why I'm interested in carbon. It's also, something I was more familiar with in terms of my background. So when you think of carbon fiber, you often think of this carbon fiber cloth, right? Like that, 3K twill weave that you see on like the bonnet of a car or something like that. That's what people think of when they think of carbon fiber. The carbon fiber I'm working with looks more like this. So this is my starting point. I start with like raw tow. So I use 12K and 3K tow. Each of those bobbins, like the one laying down and the one on the right, are 12K tow. You might be able to see in the image that it's a little bit wider. It's like a ribbon, and then on the left, that's 3K tow. So in the 3K tow, there's 3,000 individual like strands of carbon, and then in 12K, there's 12. So that's my starting point, and then that's mixed with resin to create the composite. So this is, tow/resin or carbon/resin, and this is carbon plus resin. So you merge those two things together, you're taking the properties of both materials to create a composite, and that's what gives you like the useful product. Carbon on its own, you made just a bike solely out of carbon, it would flop around, it wouldn't be useful in any way. You mix it with the resin, it locks all the fibers in place, and you get something that's, light and strong and shapeable and all of that. I should say that, and well, it's probably clear, I'm coming from an arts background. I'm not an engineer. I'm not a composites engineer. So, I'm learning all of this as well. I'm working with pretty closely with my booth mate, Matt Appelman. He's a composites engineer, and he's, helping me through a lot of this as well. I had the opportunity at the school I work at. They have a electron microscope. So I had the opportunity to kind of look at some cutaways of carbon under a microscope. I thought I'd throw that in. So this is this is actually a steerer from a Columbus fork. So I was comparing some of their layups to my layups at 5000x. So that's what carbon fiber looks like under a microscope. 2000x. And then this is 560. So you can actually see the damage here from the cut to make this section. Okay, so that's materials. And then methods. This is what I think is kind of maybe like unique about July bicycles and like really where my interest lies. So I'll talk about this a little bit. As a point of contrast, this is maybe how a carbon fiber bicycle, like a mass-produced carbon fiber bicycle is made. This is probably the most common method for making carbon fiber bicycles. So you'll have a very large stainless steel clamshell mold, pre-preg composite or carbon fiber will be laid up in that mold, and then a bladder will be inflated to create compaction. this is a great way to make a bike. It's a much better way to make a bike than the way I'm making a bike. But it doesn't necessarily allow for the types of customization, especially at the small scale that I'm working at. They have to recoup the cost of that tool in the frames, and so you buy a Trek or a Specialized or something, and there's 5 sizes available. I've developed a system where I can fully customize not only the geometry of the frame on a per customer basis. Can you all hear me? On a per customer basis, but also the tube shapes and the layups and things like that. So in order to do that, I developed this little kind of like micro factory. And so maybe the kind of question or the provocation here is, can you 3D print a bicycle using like accessible desktop tools? And I think the answer to that question is probably no, or at least not one you would want to ride. But you can 3D print all of the kind of the tools and the molds to then make that bike. So that's my starting point. I use like a little cluster of open source desktop 3D printers. Are y'all familiar with 3D printing and desktop 3D printing generally? So the process I use most is what's called FDM. It produces parts that look like this. You take a thermoplastic that's in one diameter, you squeeze it through a heated nozzle at a particular temperature, at its glass transition temperature, it comes out smaller, and then you basically build it up layer by layer. Think of a hot glue gun that's controlled in the X, Y, and Z axis. And so that builds these parts. Those tools are open source. They're open source hardware, and what that means is that the companies that produce these tools also publish all of the documentation for both the electrical and the mechanical components that make up that printer. The idea here is that not only could you replicate that tool, but you could modify it to your own purpose, or you could modify it to your own purpose, improve it, and then republish it for someone else to make. Yep.
What's the idea that the strands going down between the feet?
Great question. So that's what's called support material. And so imagine like extruding a material out into space. These printers are generally only able to print a 45-degree angle of overhang, maybe a little bit more. So as it's stacking each layer, it needs something to build upon so that it doesn't droop. So if you get too far over 45 degrees, the print will start to droop like this. And what that support material does is it creates a surface that the print can land on. Yep. So that all gets broken away. You can see it, there's a little bit of an air gap there, and you can come in with a pair of pliers or something and chip that away, or if you're using 2 materials, you can dissolve it.
And what material is that?
That's ABS, so it's a styrene. It's like what most injection molded stuff is made out of.
Positive, but then you make a mold out, and then put the carbon fiber inside that? Or?
We'll get to it. Yeah. So I made this little like kind of micro factory, right, using those 3D printers. And so the 3 tools here are a purpose-built 3D printer that has a lot of height. So think of like a bicycle tube. You need like a long skinny part. So I needed a printer that was able to print that shape. A 3-axis filament winder. This is what actually places the carbon toe on the mandrels as I'm making the bike. And then a frame fixture. And so there are commercially available like versions of all of these, but I decided to kind of design and build my own for this particular process. So this is the purpose-built 3D printer. It's got an independent Z-axis. So the Z-axis is actually decoupled from the X and Y axis. You could make this printer any height you want. It's mounted with a French cleat to the wall. Right now I have it set up to print 1 meter in height, and it has about a 6 by 6 inch XY kind of envelope. So for example, here is the over mold for, what is that? That's a chainstay being printed on this machine. Again, it uses open source electronics and open source mechanical components. Those things are kind of like mixed in with readily available hardware, aluminum extrusions, nuts, bolts, end stops, things like that. So all of this gets designed in CAD. Any parts that I can't buy, I 3D print. and then assemble into a functional 3D printer. So here's a little teaser video. I made it for Instagram, so it's like vertical video, 2024. So here you can kind of see the extrusion starting, and then that's the start of a mold, and then the end. So I'll go into a little bit more detail about, like what it's printing in a second, but that's one of the tools. The next tool is a 3-axis filament winder. So this is the tool that actually like winds the carbon fiber around the mandrels to make the tubes of the bike. Again, it's open source. It's using open source electronics. So this is a Duet board and a Raspberry Pi. What's cool about this is I can set up the G-code and I can run this machine from an iPad or my phone. It feels very high tech. Also 3D printing all of the components for it. So here's an example of a 3D printed chuck using multiple materials. So it's a mix of rigid and flexible plastics to create a chuck that can hold my printed mandrels on the machine. Completely unnecessary, but thought I'd go for it. And then anything that was maybe going to get coated in resin repeatedly, this is the tow delivery head. I CNC machined out of aluminum or printed it with an SLA part, so I could easily replace it or clean it. So this is the tow delivery head. And here's another teaser video of that. So I can program this machine to lay the carbon toe down from about a 15 to a 90-degree angle on the mandrel. So it traverses the length of the tube back and forth. That's your X and Y. Your X, and then the rotational axis is your A axis, and then the toe delivery head itself actually like rotates to account for the fiber angle and lay the toe flat down on the tube. That little triangle there, it's running dry in this video, but a piping bag for cake icing gets clamped in that. So you know how you decorate a cake? I cut one of those bags and I fill it with epoxy resin, so I determine the amount of epoxy I'll need for the tube. I pre-mix it, I put it in the piping bag, and then the toe is wetted out in real time as it gets laid down on the mandrel. So here it's like winding, I think that's like a 45-degree angle, and so it'll go back, you calculate how many times it needs to go back and forth to fully cover the tube, and then you end up with 2 layers of carbon that are going plus minus whatever angle you program it for. And then finally a frame fixture. So they're commercially available frame fixtures, for metal builders. I would love to have one of them. They're very expensive. So I thought I'd make my own kind of lower cost frame fixture for composites. So one of the reasons that frame fixtures are so expensive is because they have to counteract the forces of the metal wanting to move, and they have to, be able to tolerate heat and things like that. For composite frames, none of that is true. So this is a frame fixture using readily available aluminum extrusions and 3D printed parts to hold everything in place. It uses a series of blocks that are printed at set angles to, for example, hold the head tube in place or set the bottom bracket drop, so on and so forth. So here's an example of how a frame goes into the fixture. So the tubes are all mitered, and then they're placed in the fixture dry. Everything is checked, and then it's bonded together. The other kind of interesting thing about this fixture maybe is that it's actually part of the 3D model that I'm making for the bike, and so I can take all of the measurements off of the 3D model to adjust the fixture. I can also kind of hold, seat stays or whatever in place as needed. Yep.
Are you bonding those joints?
I'm using a structural adhesive with an overwrap. I'll talk about it in a little bit more detail here. Yep. So those are kind of the 3 tools. That's like the factory, complementing the other kind of desktop 3D printers that I didn't show. And this is kind of how it looks. It fits in an area about yay big. So it's pretty economical in terms of tooling. So how do I make a bike? The geometry is designed in BikeCAD. BikeCAD's a parametric modeling application. I think most of the frame builders here probably use it. I think they're exhibiting here also. So I use their program to figure out the geometry of the bike, and then I output that as a 2D drawing and convert it into like a 3-dimensional model. So I use a modeling application called Rhino. It's a NURBS modeler. It's kind of a surface modeling logic. It was developed, I think, initially for like the boat building industry. So I'm designing these bikes by kind of lofting surfaces together to create volume. And so this for me is like the fun part, like the design process where you can kind of convert that 2D drawing into an actual three-dimensional object. And you can see that the frame fixture is actually part of the model. So for example, there, the seat stay holder, I can Boolean out the shape of the seat stays to be perfectly held in place by the fixture as I'm bonding everything together. Something about composite frames, when you're putting them together, you get one shot. Like you glue it together, it has to be perfect. It's not like a metal frame. I can't bend it one way or the other afterwards, so I have to be like as precise as possible in this process. So once that's done, I'll start 3D printing all of the molds. I'll also very often like print just kind of one-to-one kind of versions of the frame components to check for fit and to like actually make sure in physical space the design looks the way I think it's going to look. And 3D printing has become so kind of affordable and accessible, at least FDM printers, that I can do that. And so, for example, here on the right is me trying to figure out like a seat stay yoke or juncture. I was testing for clearance for tires, seeing how the brake would look on it, things like that. And that becomes a feedback loop where I can look at that part. I can say, oh, I need to move this a millimeter or two. And then I can change to the model, print another prototype, check it, and then once I'm happy with it, I can go through and make all the molds. This is carbon now, so smaller parts of the frames, things like dropouts, they're compression molded in 3D printed clamshell molds. So the dropouts on my bike are, I guess, what would often be called like forged carbon. So it's a combination of tow and like small chopped strands of carbon that are compacted in a mold. So I use like a clamshell mold in conjunction with a vacuum bag and some other trickery to get compaction. And these are the parts right out of the mold. So you can see the little bit of flash on the part. That's the extra. These are solid. Yep. So you can see the flash kind of coming out of the part. You can also see a little bit of the process if you know what you're looking at. Some of the other components of the frame that need to be hollow, I'll 3D print cores. So I'll use dissolvable filaments. There's filaments out there that will readily dissolve in water or other chemicals. There's a filament called Aquatech X1. It's a really high temperature water dissolvable filament, and so it's that tan material you can see down there at the bottom right. I can calculate the thickness of the carbon for the part, offset the core in the 3D model, print it out, and then I can wrap that in carbon fiber, mold it and cure it. So this is like kind of mid layup on the carbon part. I don't have a ton of photos of like the actual process because usually my hands are gloved and sticky. So, like to take these photos is like, I'm like wasting gloves, and I'm constantly playing the game of how few gloves I can use in a day. So I don't have a ton of photos of this, but that's kind of how it looks as I'm making the part. Once the layup is completed, I use a semi-rigid kind of outer shell or clamshell mold, and that's what you see on the left-hand side of this slide. That's that red material. So you can see the gap between the tan and the red. That's where the carbon will go. And so I think this is like maybe the most unique part of the process. And so I'm using 2 or 3 thermoplastics in conjunction with each other, each with different characteristics or properties, to create, like a lightweight, well compacted part. And so what happens with this is it's stable at room temperature. So that red part, like ambient temperature is stable, it's a rigid part. And then it gets put in a vacuum bag. So this is a vacuum bag. The green is the bag itself. The white is what's called breather. So that lets the air flow around the part. And then all of the air is sucked out of that bag. And the atmospheric pressure creates compaction on the carbon. This goes in an oven, not super hot oven, think like proofing oven kind of temperatures. And that outer shell or material deforms just enough that it creates compaction on that core. So, you know, like if you pulled this out of the oven, you could basically just peel that mold right off. And so you get like really well compacted parts right out of the bag. So that's like a version of that on the right there. Once that's done, it'll get, you know, soaked in water, and the core will dissolve out. Usually I can get most of the core out just mechanically. Like I can pick it out with a pair of needle nose pliers and just leave it in the water for a little bit and dissolve it out, and it works really well. The finish, if you look at the bike in the show, you'll see the striations, or like what word am I looking for? Sorry, I'm nervous. You'll see like the process embedded in the bike is what I'm trying to say. So if you look at my tubes, they're a little bit different than other carbon tubes. They'll have this kind of horizontal striation in them, and those are the layer lines from the molds themselves. So I try not to sand carbon like as much as I can. Try to leave it all there because, you know, it's structure, and so you'll actually see the process in the parts if you look closely. Yep.
Is that just like a TPU or?
So it's a foamed PLA. If you're looking for it to buy it, there's a couple companies that make it, but the one I found that works the best is it's a company called Color Fab, and it's marketed as high temp lightweight PLA, and people use it to make drones and things like that, where you want a really lightweight structure. And what's cool about it is you can print it at different temperatures, and it will expand to a different degree depending on the temperature you print it at. So I'm usually expanding it about 2x, so it feels like foam, but you could expand it more or less than that. And so, yeah, that's the material. Yep.
So you're using the core more for geometry constraint?
The core pushes back against that, and
okay.
yep.
The core will expand out a bit, or it just the core being solid?
The core's solid, and then that outer shell like compacts in on it. Yep. Here's an example of how the tubes are made. So I 3D print 3 things to make a tube. I 3D print a solid core. So on the right here, you can see the kind of gray part, cylindrical. That's ABS, and then it's got like a hole down the middle. I'll put a piece of threaded rod in there. Sometimes I make these in multiple parts. So like with a trapped core, I could pull the mandrel out from different directions, and I can make like more complex tube shapes that way. So that's your core, and then there's a TPU sleeve. It's a single wall TPU sleeve that kind of acts as a release. So that's stretched over the tube. It's kind of like rolled on. It's a very tight fit. It's an elastomer. So think of like a rubber band fitting on top of the tube. And then the red sleeve itself is offset based on the thickness like of the tube. And again, the same thing is happening. It goes in a vacuum bag, gets wound, goes in a vacuum bag, it's cured, and then I peel the red part back off. This is the winding process. So I talked about this a little bit before, but you know, I can customize pretty much everything about the tubes, well, to a degree. So tube diameter, tube shape, and then the layup itself. So how many layers of carbon there are on the tube, which would determine the thickness, but also the orientation of those fibers, which will determine the kind of the characteristics of the tube. So if you want a tube that's going to like counteract a twisting force, you know, maybe you would do more layers that are like a 45-degree angle. If you want a tube that's going to resist like crushing, you would do more hoop layers, kind of at a 90 to kind of push back out. So you can really like tune the characteristics of the tube on a per frame or per rider basis. And again, not a composites engineer, so this is very much something I'm learning and figuring out, but it's kind of an interesting process.
Less than 45 degrees?
Hmm?
Can you go less than 45 degrees?
I can go between about 15 and 0. So when I go like really steep, I'll put a catch ring on the end. So it's like, imagine like a bunch of little spikes kind of sitting on the end of the tube, and then the toe will catch on that. Yep. And what's happening here, there's like a dwell at the end of each tube. So if you look closely at this image, it's a little hard to see because it's bright, but there's a bulb at the end of each tube. And what's happening is when it traverses and it meets the end of the tube, it does an extra rotation or two, and it locks the fiber in place, and then it goes back the other way. So with like a 45 or a 30, I can get away with just wrapping it a couple extra times to lock it in place. But if you go steeper than that, you have to catch it, and that gets trimmed. And so this is the kind of bagging and curing process. So on the left there is a vacuum bag that's made in the shape of the tube, a little bit of breather, and those little spots there where the excess resin is getting sucked out of the layup. On the right here is the tube actually being cured in an oven. So the tubes cure for about 4 hours after they're wound in an oven. The oven is like a proofing oven. The temperatures are pretty low because I'm using the thermoplastics. So they're curing at about 120 degrees depending on the part. It's a modified filing cabinet. So RISD was throwing away a filing cabinet. I probably shouldn't disclose that. It's a very professional oven. So it's a modified, RISD was throwing out a filing cabinet, so I insulated it with 2 inches of rock wool and built up a galvanized interior. And then there's this whole subculture of people who smoke meat. And so they buy very, very expensive control units for their smokers. And that is the perfect thing to control this oven. So I have like an electric heating element in the oven and a fan, and then there's a PID controller where I can set the ramp rate of the oven, and I can ramp it, and I can actually log it on a per tube basis. So I have a record of the frame curing. So there's little thermistors in here that are constantly checking what the temperature is in the oven, and then I can tape one to the tube itself. So it's a pretty controlled kind of curing environment. And then it cures under vacuum the whole time. So there's a vacuum running that ensures that the tube is under pressure the whole time. Once the tubes are made, they're mitered. And I use 3D printed, why not, right? I use 3D printed mitering templates. Some people use paper templates. The reason I use 3D printed miter templates is so I can get alignment of those templates along the tube. If you use a paper template, there's a possibility that you could introduce a little bit of twist as you're putting that template on the tube. So I've got these flats on the miter guides themselves, and so I can ensure that they're perfectly aligned along the length of the tube when I place them. So these get extracted from the 3D model of the bike, and I know exactly where to place them on the tube so that everything fits together later. I can also do that to the more complex parts. So this is a miter template for a chainstay yoke. And so that helps me line up exactly where I need to miter the junction for the bottom bracket. And again, because everything is digitally fabricated, I have the 3D model as reference. I can export all of these parts and kind of work back into the physical objects themselves, which is interesting. You'll see here, I'll talk about it a little bit here, there's a step section on the end of that. The yokes and the junctions, they're all designed so that they can be bonded to the ID of the tube. And then there's a second step in that for an overwrap. So all of the components of the frame are both bonded and then reinforced with additional carbon at that junction. And that little step allows me to create a pretty seamless transition. So there's not a big bump at the overwrap. So that's why there's a step on the part. This is what a bike looks like before it gets bonded together. So I miter everything, and then I scuff up the sections that are going to get bonded, clean everything really, really well, and then it goes into a fixture to get dry fit. So that's what the miters look like. I'm mitering just with a Dremel and a carbide bit. So the 3D print is hard enough that I can run the Dremel right up to it, and then I can coping it a little bit so that it fits onto the part. So it's very much handwork, digital craft, right? So the initial connection is done with a structural adhesive. This is 3M DP420. So it's bonded in the fixture. It's almost like a weld. That's built up a little bit, and then it's smoothed out. So it's hand filed so that there's a smooth transition between each of the tubes, and then that gets overwrapped with additional layers of carbon. So this overwrap is tapered. You can kind of see it from the tube to the head tube itself. It's a tapered section of layers and layers of carbon. So that overwrap is about the thickness a little bit more of the tubes themselves. and that creates like additional kind of structure in the connections between the tubes. So if you look at like one of my bikes in profile, you'll see a little bump from the tube to the, from tube to tube.
Are you putting the overwrap on manually with your hand?
Yes. Yep. So something so here's some of the patterns. So this is what it starts to look like. And like a lot of it are just kind of straight sections. Kind of think of how like an athlete might wrap a joint. You know that like the tape that you see athletes use, compression tape? That's kind of how I'm thinking about wrapping the junctions. You're kind of thinking of like the forces that are going to be acting on it, and you're countering that with the carbon. So it's a mix of unidirectional fabric and tape, and then the kind of final layers are carbon fiber cloth that are actually cut in very specific patterns so that they wrap back around the junctions. And that's something I can also extract from the 3D model. So I can take the 3D surface of, say, a head tube junction, and I can like kind of flatten it out, and it becomes a pattern. I can cut that pattern out and then wrap it back onto the bike, and you get a pretty seamless junction. So it's a lot of handwork. This is probably the hardest, most labor-intensive part of the process. So this, depending on the junction, I'll 3D print again those foam overmolds, and it goes in the whole bike goes in a vacuum bag like this. So there's another curing cycle where the whole bike goes back in a bag and it gets cured. And so this bag is like this huge envelope that wraps around the main triangle and then comes back in to the, kind of the rear seat stay, chain stay triangle. So when it comes out, it looks like that. So the kind of interface between the bag and the part is either 3D print or peel ply. So peel ply is a material with a really tight weave that doesn't stick to the carbon, and I can remove that, and so you get this kind of textured surface.
How do you remove that?
You can usually just peel it back by hand. Yep. And then there's some tape on there, that's flash breaker tape, so that the junction doesn't kind of spread out or epoxy resin doesn't get onto the rest of the frame. I'll remove that and then sand the transition down a little bit, and then that becomes the finish on the bike. It gets sanded, and this is what like a raw frame looks like once it's out of the mold. And then this is Jordan Lowe. He's here. He's a frame painter that I've been working with. He's great. And so this is, a frame getting clear coated. This is actually the frame that's in the show. And then it ends up looking something like that. So, yeah, that's the process.
Obviously, how long would it take you to build a frame?
I don't know. This frame, like kind of nights and weekends and like really late nights, took me, 3 weeks, a month. They're very labor intensive and time consuming. But that's like new file. So that's designed to bike. And I think that's something that's like really interesting about these bikes. I'm not just, I'm not making the same bike over and over again. If I was, and I hope to in the future, is maybe make additions where I'm like repeating the same design, maybe in different geometries. I think I could make those bikes more quickly. A tube takes about 20 to 30 minutes to wind and then 4 hours to cure. The overwrapping takes me an entire day. That's like a day blocked out to overwrap all the parts, get it cured, and out of the oven. So probably 2 weeks to a month. And then there's, finishing and paint and all of that. So it's very, very time consuming. I thought bikes were really expensive until I started making them. Yeah.
What's the genesis of July?
Great question. I have no good answer to this question.
Sitting around one July and you decided to build a bike?
Well, kind of, yeah. The first frame was made in July, and my last name's Jurgensen. I didn't want to use my last name. I don't know why, just, something different. So JU. I was born in July. The tour's in July. People are thinking about cycling. So I thought it would be like a nice name for a bike brand. So it's July, or maybe it's going to be Ride July. I don't know. I don't know which one I like better. But that's kind of the genesis of the name. And yeah. July bicycles. Yeah, other questions? Yeah.
What do you do for the bonded in? It's like the bottom bracket shell.
Oh, great question. Yeah, yeah. So these are from Paragon Machine Works. They're T47 bottom bracket shells, and they can be aluminum or titanium. This one's aluminum, and it's isolated with a couple layers of fiberglass, and then, yeah, molded into the bottom bracket junction. Yep. Yep.
What kind of oven do you use? Do you use oven?
Yeah, so it's like a custom built. It's like a cabinet that I insulated with rock wool, and then I use a control, like a PID controller, to control the temperature.
Can you use the ordinary house oven, normal kitchen oven?
I mean, you could. I wouldn't want to eat out of that oven after I cured the parts, but I don't. You know what? I don't know if a kitchen oven would have the right level of control. Yeah, like like if you bake a cake or a pizza or something, you got to turn it.
I've baked painting.
Yeah.
You have to stick the back end in, and halfway through without touching the paint. Chairs and everything is propping it all up in somebody else's home. You take it out, you put it running, put it back in.
Yeah.
And I was going to ask you about temperature for baking and all. You talked about 125-ish degrees. Is that centigrade or Fahrenheit?
Fahrenheit.
And after you finish the frame, is the frame limited to a high temperature?
No. So the resin system I'm using can withstand a much higher temperature than that.
So you can cure the paint you're using at a higher temperature, as an example?
Absolutely.
Okay.
Yep. Yeah, I cure at the low temp. Like I could cure at a higher temperature. I could snap cure the resin, but I'm using the low temperatures because of the thermoplastics. Right. So the plastics themselves kind of can't get above certain temperatures, right. Or they'll start to deform. Right. And so I've really I found this window where I can get all of these things working together really, really well, and end up with a really kind of consistent outcome.
Yeah.
Yeah.
Were you a little nervous on your first ride on your first bike you ever built?
Absolutely. Yeah, pretty nervous, but
Your first big descent, you're like,
You did go bombing down to.
No, I mean I went for a pretty long ride. It's like I rode it and I was like, this thing's just good, and then I just kept going. It was riding something you built is really, really satisfying. It was great, but I should say too, I overbuild the frames, so I think they're very much overbuilt. So they 900 grams, 1,000 grams, depending on the size.
frame upstairs, what's the weight without the fork of the frame upstairs?
I don't know with the fork. I think the fork probably weighs 900-ish grams.
That's pretty good then.
It's pretty light, but it's.
Do you make the forks also then?
I don't.
Okay.
So the bike in the show is a number 6 composites fork.
When will you start making forks?
I don't know. Maybe for a personal bike, but
It's like the hardest thing.
yeah, it's kind of dangerous. Single point of failure. I don't know. Oh yeah. Thanks for coming. Yeah.
Have you thought about disc brake?
Yeah, I made a couple disc brake frames. I should show more of them. I'm not super happy with my design for the dropout. It's a little bit heavy. So you can see it here. It's a little bit heavy and it's a little bit thick. So I'm working on a new design for the dropout. But the next couple of bikes I'm going to make are all disc brakes. So yeah. Other questions? Yep.
I guess along with the dropouts, so when you're doing your forge parts, you kind of mix up the chop and the toe, and you kind of slap it on each side of the mold and then compress it, or what's your process there?
Yeah, it's a little bit of that. There's a vacuum bag involved, and then I also use some plugs to add compression. So I basically I'll figure out the volume, and so I have a sense of how much material I'm going to need, and I can do that in CAD. So I can find that negative space, figure out the volume, roughly know how much chop and how much resin I'm going to need. I also run lengths of tow through the dropout, so it's not just small fibers. It's kind of like a multi-part process. I'll start with the smallest fibers on the outside of the mold, go a little bit bigger, and then as you get to the center of the dropout, it's pretty much full lengths of tow, kind of running that shape. And in designing that part, I'm designing it so that I can really run the tow through both sides of the dropout. As I'm laying it up, probably 3 or 4 times. I'll throw it in a vacuum bag and I'll compact it because there's no way I could kind of do it by hand. Once I get it to the point where it's like a hard, like compacted mound on either side, I'll clamp the 2 clamshells together, and then there's plugs on either, like perpendicular to the seam of the mold that like then further press everything into place and push the resin out of the seam. So, yeah. Yep.
You mentioned you're trying to work with some different tube shapes now that you've kind of played around with it. And are there any limitations on what kind of shapes you can wind, since you're just kind of a winding apparatus?
There are, yeah. So I'm limited a little bit in terms of like, kind of transition in diameter. Like for example, I don't have a great picture of it in this slide presentation, but the top tube on this bike is kind of an hourglass shape. And it was a pretty tricky thing to wind. I had to kind of program it as 3 separate tubes to kind of change the rotation and get the fibers to lay down flat on that. The mandrel was also pretty complicated on this. Well, not pretty, it's a little bit more complicated. It was like a 3-part mandrel with trap nuts on the threaded rod so that I could release the mandrel out in opposite directions, because otherwise it would have been trapped in the core. So to answer your question, I'm a little bit limited in terms of like how different the shape or diameter of the tube could be in any one point. And then also a little bit limited in terms of like, I've got to be able to get the core back out. And I haven't tried yet on a full tube length doing a dissolvable core. It would work, but it would be very expensive. So I try to design the tubes so that I'll be able to get that rigid mandrel back out. And then I can reuse those. So I can reuse the rigid section and the flexible sleeve. And on the larger diameter tubes, I can reuse the outer mold too. It's a thermoplastic. It has a little bit of memory. So, I have a heat gun that has like a temperature sensor on it. So I can set that for like 250 degrees, heat up the outer mold, peel it off very carefully, like I'm peeling an orange, and pull the part out. And then if I heat it back up, it'll usually go right back to its original shape, which is pretty cool. Yep.
How does your process differ from high Fesca and 51 bikes like their frames?
It's not that different. I think the difference is really the use of the 3D printed like outer molds and the for both the tubes and the junctions. So like Fesca is using filament wound tubes, and then I believe their tubes are compacted using tape, like compaction tape. So like if you look at a Fesca, you'll see these like kind of lines on the tube, and that's from the tape. So that tape gets wrapped around the tube after it's wound, and then it gets heated and it shrinks to create the compaction. And then they're, I think, doing tube-to-tube construction. So they're mitering, there's a bunch of like kind of filler to build up like a fillet, and then they overwrap it. Yep. I'm trying to get as much, like each bike I get further and further away from the idea of like tube-to-tube construction, and I'm trying to make each of the junctions so that I can basically just plug the tube in. And that's maybe more similar to how like an Argonaut or a Pursuit Cycles does it. And that cuts down on the labor and gives me a little bit more control.
It's kind of, some of the trucks were made where they had, I'm assuming cast ends, and they inserted over in the tube.
Oh, like metal, almost like lugs?
Yeah.
Yep. Mm-hmm.
Yeah, that's the way the OCLB bikes were.
Yeah.
Yep.
Yeah.
Yeah, because I've got samples of the heads.
Yeah,
and the
exactly.
tubes.
Yeah.
Yep. Yep. Or like Colnago has the carbon like lugged bikes where you see the lug on the exterior of the tube.
Calfee does lugs.
Calfee does lugs. Yeah, they do lugs, and they also do overwrap. They have that really cool like overwrap toe, very organic kind of junction.
You said you 3D printed your dropouts?
So the molds for the dropouts are 3D printed. But so this is what a dropout looks like. Where is it in the slideshow? I don't remember. So this is like a dropout right out of the mold, like that. So you can see a little bit of flash that gets forced out of the mold, and then you can see where There's like these little like cones, also extra area for, you know, resin or carbon to escape, and then I can just cut them off. The through holes here get machined out, so it's a solid part. I tried dissolving those out, but I could never get it to work perfectly.
One of the other frame builders said that building just brake bikes are harder. Is that just for steel, or is that, or does it?
I think it is. I started with rim brake bikes because it's a little bit easier. You have a little bit more wiggle room in terms of, you know, like, you know, the relationship between the axle and the brake mount, especially with like a flat mount brake. And then, you know, like with a through axle, the dropouts have to be perfectly aligned. With a rim brake bike, you could come in and file it a little bit and you'd be okay. So yeah, it's a little bit more complicated. And then for me, they get heavier because this part is solid. So like that section of the dropout is much larger than the dropout would be on a rim brake bike. And so I'm trying to figure out how to remove some mass and weight there. Yep.
Have you thought about drilling them out at all?
Yeah, what I've kind of arrived at is like more of a tapered shape. So it gets a little bit thinner. Yeah. Other questions? Yeah.
Is there like a structural reason for not doing like the bottom bracket shell assembly in like a compression molded, or is it a weight consideration?
It's really, for me, it was like a complexity thing. So let me see here. It may be risky opening up photos. Here's some exported things. So for this workshop that I did in Doha, I precast all of the junctions for the bike using that process. So these are all dissolvable cores. Maybe I have some pictures of what that looks like as carbon here.
Still using that bike sheet?
I am not. I don't have pictures. Let's see. So, sorry, I'm searching through files. So like this is what one of those junctions would look like as a cast part. And then it's made with, again, with that double step so that the tube just goes right into it, gets bonded, and then you have opportunity to overwrap it without creating too much of a bump. The reason the inside of that tube is white is I'll do the first layer in fiberglass, and that way, like I print the part a little bit undersized, and I can ream it out exactly to tolerance. So that's what's happening there. So this is just a standard like 44 millimeter head tube, but I can also do like bearing races or whatever. Yep. Any other questions? Yeah.
Is it easy to like balance out the stiffness and strategy across a range of different, or is that sort of trial and error?
Yeah, that's still something I'm trying to figure out, is like ride quality, stiffness, all of those things. So that's that kind of feedback loop that I mentioned, and you can add a little bit more material here or change the layup, and you feel it. Yeah. Yep.
Are you using software to analyze the toe angles?
I'm not.
Okay, so you're just
Yeah.
iteration.
Feel. Yeah. That would be great, though. I would love to do that. I would love to.
People to do that.
Yeah. Hey. Yeah, I would absolutely. Kind of love to get more technical with all of this, but yeah, I guess I should say too that and that was something that was like true of this workshop. These students are all, they're artists and design students. They're not frame builders. And so we were building bikes, but we were thinking about composites and accessible composites in conjunction with digital fabrication tools. So, we were talking about, how could I use this to make furniture? Or I'm an architect, how could I use composites as, like a decorative facade on a building or something like that? And so, that's what we're kind of thinking about in these workshops. And that's where I think there's like maybe a more universal application for a lot of what I'm doing here. Yeah, I don't know. I think these processes really complement each other in an interesting way. And yeah, I'm super excited about it. And I think they were, so that was cool to see. And yeah.
What's your feeling on like riding the different iterations of your bike compared to like other carbon fiber, like mass produced or engineered bikes, like just the experience of the ride?
I mean, to be completely honest, I don't have a ton of experience riding like really high-end carbon bikes. Most of the bikes I've owned are steel or aluminum, and you know, that's kind of my reference point. You know, I've borrowed bikes and ridden them, but haven't put, you know, tons of miles on them. So, again, still learning.
Have you had other people that know about them try your bikes versus?
Yeah, people seem to like the ride. Yeah, I've had people, you know, there's a couple of them out in the wild, friends who ride them, I've loaned them out, you know, riders of different size, weight, power output. So I think because they're a little bit heavier, a little bit thicker, and maybe because of the tube-to-tube construction, they ride a little bit smoother maybe than like, you know, like a monocoque frame. I don't know.
What's your experience like going from your previous bike to the first one? Like I know I've jumped from material to material, and I distinctly remember going from a carbon bike to a tie bike. Tie bike was very impressive.
Yep.
When I went back to a carbon bike after that tie bike, it was a little more modern. It was stiff, but all those things they say about carbon bike.
Yeah.
All of the way everything else disappeared.
Yeah.
Curious.
Yeah, I mean, I feel maybe the thing I noticed most though is geometry. Like the first bike I made, the geometry wasn't great. It was really twitchy. And so, you know, like you really notice like the shift in a head tube angle or chainstays being a little bit longer or shorter or whatever. So you really notice those things, and maybe the carbon less. But yeah, bottom bracket flex, I think really kind of noticed. I played with that. I tried making like really stiff bikes, and you can. So yeah. Great. Well, thank you for coming.